Good afternoon, everybody. How are you guys doing today? Okay. Okay, it's my pleasure to be here. My name is Piech. I'm going to be talking about scaling high-quality education with AI and tutors. But maybe the subtext is something I always think about is like, how do we make sure that the future of education remains joyful? And it's going to be a bit of a talk, but it centers around a story. So gather around and let me just bring you on a small journey about education with some algorithms. As a brief introduction, my name is Chris. I'm a professor here in the computer science department. I teach a few classes like Introduction to Computing, or to Programming, as well as Probability class, and every once in a while an Intro to AI class. I have a research lab in AI for education, and something that's not at all important is I actually grew up in Kenya and Malaysia before I came to this wonderful university. 10 years ago today, I had the distinct pleasure of writing what might have been the first paper to use this new technology called deep learning in education. And there is a kind of a nice part of this story. I actually started on the Caltrain. So I was sitting next to this fellow called Joshua Dickstein on the Caltrain, and I was really excited about this technology. I was pretty sure it could help us understand students. Like we could use this new technology, use big data sets, watch people learn, and then have an idea of what they know and what they don't know. He had recently worked at a place called Khan Academy, and we started this collaboration. And it worked quite well. Like we could look at sequences of student interactions and predict how they would respond to different questions. It was a very exciting moment 10 years ago. This is also not that important, but he just finished a different research project that ended up being this thing called diffusion. And sometimes I wonder I should have helped him with his project, but that's not important right now. And the same year, when we did that, we built these big deep learning models. They would process all these students on Khan Academy. They could predict student futures, but it felt very hopeful. They could do other things too, like they could look at the math curriculum and figure out which concepts were really necessary to master before you could move on to other concepts. The same year, I got really excited about code education. We would get really creative about deep learning algorithms. This is one where we took the hierarchy that is the abstract syntax tree of people's programs and built bespoke neural networks to understand programs from first principles. And we got really wild. There's even a moment where we would take preconditions of a state of code, put it through a neural network to embed it, put code through a different neural network, interpret one as a matrix, multiply it, and get a postcode. It was exciting. And it really felt like we could start to see the needle moving in some ways. And you can imagine, as a younger researcher, this was exciting. And I went really looking for algorithms at this point. I picked 4 that I went to, but there's others that were just as exciting. Just to highlight a couple, one of the things I got really excited about was generative grading. There was this open question. We can't do AI for education with just one example, even though a human can just look at one example and really get insights. And similarly, at the time, AI couldn't recognize handwritten digits unless it saw millions of examples of the handwritten digit. But there was a breakthrough coming from Josh Tenenbaum's lab in MIT about how we could think about probabilistic models with deep learning at the same time. We brought that to education to help with grading. It was terribly exciting. There's other parts of education that I was finding interesting. There was a moment where we tried to revolutionize how people did eye tests, and we got deep into math and probability to make better eye tests. And then, one of the really fun things that we did is we worked with this company called Code.org, and they were having trouble grading people who were doing interactive assignments. And so we thought, what if we made an AI algorithm that could play with student work? So a student makes a cool game that they like, and then the AI algorithm plays with it in order to give feedback. And we were having a fun time. But then something changed for not just me, but everybody. 2019, the pandemic hit, and 2020, we all had to shelter in place. This was the most disruptive change to education in my lifetime. Overnight, 1 billion students switched to remote learning. And of course, we now can look back and reflect that it wasn't just a pandemic in illness, it was also a pandemic in loneliness, a pandemic in inequality. It was a really hard time. At this moment, I wasn't a doctor. If I was a doctor, I suppose I would have gone to the hospital and helped people who were sick, but I wasn't able to do that, so I was at home thinking, what could I do to be useful? And I thought that this was a moment with all these different flavors of pandemic when people really did need some help. So we were asking ourselves, what would it take to scale up high-quality, joyful education to help people at this difficult time? When I say we, I mean a lot of people. Like a bunch of us were trying to think about what we could do for folks. So I'm going to talk about work that has been a contribution through many, many, many people. So the social need was pressing. we were at the time where we basically had AI that could drive a car, and we were wondering, can AI just help at this moment when we have 1 billion people go online? Now, on some level, I knew that there was a hitch here, right? AI for education was hard, and there's lots of ways of telling the story of why AI for education is hard. One way is statistically. You can find any distribution or any data set of students learning anything of complexity, and you will start to see this thing that we call the ZIF distribution, which is one of the heaviest tailed distributions. It's a long way of saying that when students are producing work, almost all of their work really does look unique. Another way of telling the story of why AI for education is hard is actually just to look at people learning. So code.org and I built a data set of millions of students learning. Before we think of solutions, let's just take a moment to build some empathy and watch some people learning. What you're going to look at is a visualization of an open source data set of 1 million students trying to write their first programming problem. It's only going to be about 5 lines of code put together. Every single pink dot represents students. The bigger the pink dot, the more students. Every spot in this graph is an intermediate solution, and these students are trying to get from the beginning to the solution to a problem they're trying to solve. The edges aren't so important. Those are what teachers suggest students should be doing. So let's go watch our 1 million students learn to code. They all do slightly similar things at the beginning, and then you start to see some diversity emerge. There's a few things that I'd like to call out while we watch all these students learning. There are some people who are making their way to the final path directly, but there's also a long tail of people who are finding this difficult. One thing to note is that once somebody shows a sign of difficulty, they start to go in very unpredictable directions. We can talk more about that. And another thing is just pure empathy. This is a 4-line program without if statements, without for loops, and there is a student who spent more than 24 working hours trying to get this to work. That is a lot of effort that people are putting to try and learn. Now, I'm trying to tell a story of why AI for education was hard. One of the things that we did, naturally, was we built a recurrent neural network, and first we encoded students' programs, and then we tried to learn the temporal patterns of how people learn to code. We had so much signal and so much interesting dynamics that we thought we could learn a lot about the future of any particular student. But then we saw this result, and this one really made me think. We asked the neural network, can you give an example of a student who is most likely to succeed? And so I chose a program that did actually have an if statement and a loop. And the student that the neural network chose as like most highest probability of succeeding downstream in the future was a student who showed this really interesting phenomena. The student at the beginning had compound errors, like problem upon problem, managed to solve one of the errors, has a reasonable attempt that was wrong, backtracks, and then finally gets to the solution. And this was substantially higher probability of making in the future than the student who just was able to solve the problem directly. And of course, this tells us a story that we already know, that we have to be very careful about many things in education. One of them is this idea of learned helplessness. Like this ability to solve your own problem, to have that problem-solving skill where you can backtrack, can be incredibly important. So putting all this together, I knew that AI for education might be hard, but there was this fierce urgency. We had to do something at that moment. And just one other piece that I wanted to add to the complexity is I was aware that digital education wasn't a panacea. We were seeing more and more digital education, and that was not correlating to students getting further and further. What you're looking at here are PISA test scores, so global scores of students' abilities to do things like mathematics, reading, and science. And this is average for countries over time. And you can see that math, reading, science, they're not getting better as we're adding more technology to the equation. So the mystery. It's the pandemic. We've been sitting on all these wonderful algorithms. It was time to help people learn which one did we center. Yeah, little suspense. You gotta build some drama. We wanted an algorithm that could inspire students, avoid learned helplessness, have long-term benefits. And there was one algorithm I did not invent, but I'd seen that I would argue is the most amazing algorithm I've ever seen. It's the one that exists at Stanford's Intro to Computer Science. So you might not know this, but if you took the CS 106A class here at Stanford, there's a real secret sauce. When I teach the class, we might have something like 500 students, but they don't just all learn from me. Instead, once a week, they all meet in small groups, and those small groups are led by a person that we call a section leader. That's somebody who's taken the class, maybe taken a second class, but then we've hired them to come back and teach. And that's really the secret sauce to this class. And I don't have time to wax poetic about how important this idea is, but there's so many things I can say. One is that it has meant that Stanford's Intro to Computer Science is one of the most human-led, high-quality education classes I could imagine. One of the other things you might not expect is the people getting the best education might be the section leaders, right? They're learning mentorship, how to communicate. They're getting so good at the principles of computer science that they're really able to go deeper themselves. But basically, it leads us to this insight. And I think this is true very globally beyond what anything I've tried. As a community, I think we drastically underestimate how many people could be teachers. If you think about changing the definition of what you consider to be a teacher, there's a lot of people who would find joy in teaching, because it is a wonderful thing to do. It is a way to learn. It is a way to bond with your fellow humans. And something that I've been learning is that the magnitude of people who want to teach is roughly proportional, and I would estimate, depending on the subject, something close to 1 to 8 to the people who want to learn. And we are not taking advantage of this enough. So that's what the algorithm we decided to lean into. We're like, can we get the section leading algorithm to scale? So we said, who wants to come teach with us? We're going to teach this class during the pandemic. 15,000 people raised their hands, which is a little bit overwhelming, because they all recorded a 5-minute teaching video. So it's kind of like a Ponzi scheme of education now, right? Like, you're going to come take this class, and you're all going to be in a group of 10 students led by a section leader. The section leader is then going to be in a group that is led by like a section leader mentor or head TA now. And actually now those head TAs are in a group that's led by a director. We've gone very far. And for us, we decided that this was the key to scaling high quality education. Okay. That has now evolved into a program you may have heard about that's called Code in Place. It got its name from Shelter in Place originally. And this is the 5th year that we're offering it. And to date, we've taught over 60,000 students, and we've had about 5,000 volunteer novice teachers. They're learning the first half of Stanford's quite rigorous Intro to Computer Science class for majors. And it's all been done as community service. It's free for everybody. Free for the students. It's also free for the teachers, which is a fancy way of saying I wish I could pay them, but I can't. But they're learning too. I do think we put a lot of energy into making sure that's a learning experience. We've had folks from over 180 countries now, all genders, all ages. One of the fun side notes is I think we've dispelled this fact that you can be too old to learn how to code. That's not important right now, but that's been a fun thing to observe. There's a lot of things to be proud of, but maybe one of the things I am quite proud of is we may be one of the courses in the world with the most teachers, and certainly one of the online courses. I have so much to say, but this thing's become Code in Place, and one of the things that's happened from having so many teachers is this beautiful growth in community. People make their own t-shirts, they make cookies, they make memes. There's a whole energy around this learning experience that has come out. Now, I could also tell the story through cookies, or I could tell the story through numbers. I like both. We've had great retention rates and teacher completion rates. People have enjoyed it. And students have found jobs, which I find surprising. But certainly section leaders have. A lot of people have used this as a mechanism for career growth. One of the things I pointed out there is that our completion rates have actually been rather large. Somebody actually asked a question earlier where they pointed out that in Coursera they were seeing very few people who come into a class make it through the other end. And we're teaching a hard class here, a Stanford level computer science class. And a lot of the people who are coming in through the front door were making out the end. And these numbers have gotten better. We're getting close to 70% hopefully this year. That has meant that even though we've only had 60,000 students, we've had almost 2 million programming assignment completions. And they can be hard. For those of you guys who have learned to program, that is a lot of human effort. I actually wanted to take a moment before I go deeper to give you a quick tour. Do you guys want to say quick tour? Because it's happening right now. I can show you inside the class. Let's go. Okay, welcome to Code in Place. So this is it. This is what students see. Right now, there's 891 students learning right now. And when they learn, of course, we try and give a roadmap. It is week 5. They're learning how to do things like graphics and program with functions. It's a mix of things like lessons, so you'll have a lesson, we'll walk you through concepts. You get to meet Maron, who is my charming co-instructor. You get to meet Carol, who is our charming little robot who helps you learn. We try and make learning as engaging as possible, a little bit affirmative. And then, of course, you do a lot of coding, too. So we'll teach you, and then you go and you actually program yourself. One of the special things, of course, is the section. So everyone will be in a section. I'm in a test section, and that has a whole bunch of folks in it. Presumably, if I was a student, I'd be meeting once a week with these people. There's a lively discussion forum. We can go see what people are talking about right now. And that maybe gives you a sense. There's events, there's connections, there's Teach Now. I'll talk a little bit more about these things. At this point, do you guys feel like you have a little bit of an idea? We can show you. I was looking at some student made this program and posted it to the forum today. And it was like a fully working Pac-Man. And the student had never programmed before. So it's just wonderful to see what students are doing. This was another one that students wrote, which would like allow you to do a tarot card and then give you a GPT-inspired interpretation. We can talk. I could get really proud of my students right now, but I'll see if I can stay on topic. Okay, so I've already given you the quick tour. You kind of have a sense. So Code in Place has evolved into something. We really want to be this wonderful class. We want to be the place in the world where you can go learn to teach. I don't think there are enough places in the world where if you want to do some informal teaching, you can go learn the skills of pedagogy necessary. But also we want to be a place where we can keep reinventing what we think the future of education could look like. Obviously, one of the big takeaways from this is that learning is not a small system to be optimized. It is not something that you just throw a neural network at, we find the max optimization, and then we just give that to students and we're done, we go home. Learning, of course, is a big ecosystem. I don't need to convince you of this, but like students have their own needs, teachers have their own needs, user experience can really matter, life schedules can really matter. I don't want to talk about time zones. Assessment methods, student motivation, all this matters, and then when you think about AI tools, it just becomes one piece of an insanely complicated system. But it has led us to the point where now when we think about AI education in my research lab, we're not thinking about it abstractly as an optimization, we're thinking about these intersectional AI algorithms. So at this point, I told you a little story of how I went from kind of a pure AI researcher to one who just cares a lot about humans. Wait, that makes it sound like I didn't care about humans before, but you get the drift. But at this moment, I want to talk about what life has been like since we've been working at this intersectional space, because there's a lot of cool things where AI maybe could be helpful. So even though Code in Place is centered around these human teachers, we have found there have been bits and moments where we can use AI to bring some joy to students. One of the least joyful moments in programming is when you get this thing called an error message, but if you do that in Code in Place, we will put that through a large language model that will turn it into really actionable insights for you. One of the important things when you learn to program is the elegance of the code you write. When you finish writing a program in Code in Place, we'll give you style feedback that will talk about, okay, you solved the problem, but could you have done it in a more elegant way? Students don't think of these as AI systems. They just think of them as tools. I don't think they ever process that they're working with a large language model there. We've gotten super integrating. It turns out I think grading is almost a solved problem at this moment. You can give me a piece of students' code, and we can give you some very good feedback. Actually, one of the ways we can tell that story is it's now been deployed. So we still work with code.org, and they're now using a grading algorithm we wrote to give automatic grading to teachers around the nation. Sammy's going to come talk later, and you can ask him about this project that was really led by a student of mine who took a class of his, where when we're giving feedback to students, we now have figured out wonderful ways to get the teacher's perspective back into the flow. So I teach a class probably for computer scientists. AI will generate 2 pieces of feedback. We'll send those 2 pieces of feedback to a teacher. The teacher will either choose one of those or write their own, and then this becomes a feedback loop so that the next time the AI generates better and better feedback for the next student. Grading, as I said, this cornerstone, we've gotten more and more exciting. I told you about this project where we're grading students' open-ended work. We're now at the point where you could give me a game a student wrote, and I can tell the difference between creativity and a bug. It's been really fun. Small things that we've been able to give to our students. But we've also been able to do feedback for teachers, thanks to Dora Demsky. When teachers come to Code in Place and they teach their class of 10 students, after we've got those transcripts, we can process those transcripts and give them insights. And thanks to Dora, we've been able to give insights that lead to teachers asking more questions, taking up students' ideas more often, and leading to classrooms that students just prefer and show up to more. But of course, the dream of AI in education can't just be feedback. I'm so glad we've achieved this milestone, but we've got to think bigger. And that's been a lot of fun recently. One of the pieces that actually uses a very light layer of AI has been thinking, well, if teachers are so great, can we just give students more teacher time? Like if you have 1,000 teachers, shouldn't we just have this wonderful ecosystem so anytime a student wants help, they can get a teacher? So what we didn't make is we didn't make a button where a student could say, I want help, and then we give them a teacher. That would have been terrifying. At 10,000 person scale, like we could have the biggest queue in the world. It also, I think, could create some learned helplessness. But we did flip it on the script. So if you're a teacher, in the Code in Place platform, you can hit Teach Now, and if you're a teacher or if you're a student who's gone through training, you can click this button, and we will search through the 900 people online, and we'll say, who do we think could benefit from your help? And then they'll get a little pop-up being like, Chris would like to teach you. Would you like them to join? This has actually been the single experiment we've done that's moved the needle the most. We found that 15 minutes with a one-on-one teacher could move the needle as much as 10 percentage points for a student completing the class. Huge impact. We're going to talk more about this later, but I'm going to tell you something hilarious. I've listened to all these conversations. I've also looked at a lot of conversations of AI playing the role of teachers. These guys make mistakes. Like, they sometimes say things that aren't perfect. They've got all the foibles that you expect from human teachers, but they lead to this really positive impact on students. Continuing the laundry list of really wonderful things we've been able to add is our teachers get nervous the first time they teach. It's very scary. So we've built an increasingly sophisticated set of tools where they can practice teaching, not GPT as a tutor, but GPT as a student, because all the mistakes that GPT makes make them very, very believable students. And so especially for English language learners who are teachers, the chance to practice teaching GPT students has been wonderful. Giving you the spread of things, though, I was talking to Dan Schwartz, our wonderful dean of the School of Education, and he was telling me about, what I guess that would move the needle the most is people being able to share their work with their loved ones. And this has really blossomed in a nice way just this year, where we were talking to some folks who do education in Afghanistan for girls, and those girls can only access education over WhatsApp, and we were talking about what CS education could look like. A couple of folks in my lab were like, challenge accepted, let's figure out how to do this. And combining the idea that Jan Schwartz said of sharing is so important, they made their first milestone. Can we make it so people can share their programs over WhatsApp? So you can write a program for your mom who maybe runs a kiosk, and then her employee or her clients could then maybe place orders through a WhatsApp program, and they could share it over that medium. More towards that end, we've gotten really, really good at taking handwritten work and turning it into digitalized work. When you're learning to program, surprisingly, the best thing you can do is walk away from your computer, pull out a pencil and paper, and try and think about your problem. Now you can do that, take a photo of it, and then upload it later. Somebody asked, are all these technologies going to mean more time in front of the screen? I actually think this path might answer no. Like, we might spend less time in front of a screen because we've gotten so good at recognizing human handwriting. Of course, this matters a lot more for developing countries and, for example, Afghanistan. The working model there is that a student will get their assignment from WhatsApp, go do it by hand. The next day, when they have time and they have access to maybe their parents' cell phone, then they take a photo of their work, get sent to us, they get feedback, and people get to run their programs. Agents. Somebody promised I would talk about agents. I actually will talk about agents. We do have a small number of AI agents, and they're maybe not doing what you expect. They are not tutoring our students. Instead, we have AI agents that are crawling over Code in Place to give us pedagogical insights. Sierra Wong and John Mitchell and I have made agents that can actually go over Code in Place, and they can predict where students will find struggles more accurately than any algorithm that we have. And it will go over a thing and be like, okay, this video you added, fantastic. I like it a lot more than this previous video. Or they can say like, this part really gets confusing for students. Or this button, I don't know how to click this button. And that's our insight that we should probably fix it. Now, I've talked a lot. At this point in the story, I've told you about this commitment to the algorithm of section leaders. I've told you a little bit about how we now can add AI on top of that into this ecosystem led by humans. What I haven't really directly talked about is, what about GPT as a tutor? Like, are we going to live in a world where AI becomes the teacher? I don't know the answer to that, but what I can tell you about is one of the world's largest randomized control trials on using AI as a tutor. So what we did in Code in Place is a few years ago, 2 years ago, we took half the students and we gave them early access to GPT-4, and the other half just had their regular Code in Place experience. The early access looked like an API that's just like the GPT chat that we all now know and use. And so we gave it to some students, and they could ask questions. And I'll tell you, we looked at the conversations they had, and they were pretty good conversations. They were having conversations on point. GPT-4 was able to be perfectly accurate for intro to coding. Now it's your turn to guess what happened to those students. There's a few ways of telling the story, but basically for all of our measures of engagement, the people who had access to a GPT tutor dropped out more. They finished fewer assignments, they took the optional midterm less, they showed up to their sections less. And we can break that down a little bit more. I think there's a lot of nuance to be said here. What I told you really applies for medium, high, and very high HDI countries. It is the exact opposite for very low HDI countries and low HDI countries. Age matters. People who are kind of between 23 and 40 are the ones who are most impacted. And people who have high experience or low experience were not impacted, but people kind of in the middle ground of experience, those are the people who are hit the most. At this point, I could give you some hypotheses, but you have to recognize them as hypotheses and not as proofs. I think that while you're learning to code, AI can be quite intimidating. You have to work really hard about learning a new way of thinking, and watching AI being really good at that way of thinking can really distract you from that process. That is especially true if you are of the age where you're looking for jobs. But I think that might be less true for low HDI countries. Maybe it feels like a real opportunity to leapfrog from some other vantage point. So there's certainly some nuance. And what I can't also tell you about is maybe our students who had the tutor were learning a lot more, and I just didn't get to see it. The only thing I really got to perceive was that they were dropping out more. Okay, and then all of this, though, maybe misses what I think could be the #1 most important impact of AI for education. I think there was a picture earlier of a student looking very bored in class. There's a lot of people who find classes not as exciting as they could be. Learning is joyful, teaching is joyful, and yet for the vast majority of people in K-12 education, they might not name it as such. But here's a book that, this is giving too much credit to me and my daughter, but I have a 4-year-old. She was 2.5 at the time of this, and she was just getting excited about books. And being an AI researcher, what I didn't do is just have her sit in front of ChatGPT. What I did do, I was like, hey, what could I do to make her love books? I could give her the sense of creation. And so I was like, I got her to tell a story. It was quite derivative based off a story that she'd recently read, but it was wonderful. And we had ChatGPT create all these illustrations. And then, focusing on that dream of generation, I then took those pictures together and I put it through Google Photos and printed it and gave it to her. And to this day, it's still one of her favorite books, and she's so proud of it. And that feeling of creation was wonderful. And that's what I think AI could really do for us. That feeling that we can make things that weren't possible before can really maybe change the narrative of education. What that means for me and my class in Code in Place is, if you go to our class right now, you'll see a lot of people talking about AI, but they're not talking about our AI tools. They're talking about the programs that they're writing that happen to use ChatGPT as an API. So we have this assignment called Infinite Story, where students write a program that takes you through a choose-your-own-adventure. But when it gets to the end of the adventure, ChatGPT just keeps the story going. Maybe I can show you what this API looks like. Oh, there's the Pac-Man one. So, here's a very simple one. So, when you first learn to program, there's not very much you can do with a 6-line program, but here's one where the user gets someone's name and a topic, and this is what we give students. We give them a function where they can call ChatGPT from their program and then get the response and then print it. So this one's just gonna say, what's your name? I'm Chris, I'm talking to Coors. We'll see if ChatGPT 4 knows. Chris speaks to the stars and whispers often dreams, Coors echoes their truth. Okay, good times. And also, this is not that important, but check this out. You can go back in time and see your variables move. Not that important, but I need to show somebody. Okay. But I think that this is more important than any AI I've given you. The AI that can tutor you is less important than the AI that can help these students make programs that would have been impossible for any computer scientist 5 years ago. And that's maybe one of my hopes for where we go. Okay, so at this point, it's an interesting moment, and especially talking to Coors, we are finally at the point where maybe because of all this digital education, I kind of want to revisit that first step. So, Code in Place, as I mentioned, we've had about 2 million assignment completions and millions of creative projects as well. I talked to core.org, they're up to billions of student codes, which they've generously shared with us. And I'm really excited to go back and see what we can learn about the science of human learning. But at this point in my career, I recognize that as an academic pursuit. Like, I'm very interested to look at all this data set to learn about how people learn. And certainly, we will turn this back to the users and give them insights about their own learning. I think that will be a wonderful thing for me to do to learn, and I can't wait to make that tool. But the end, not the end. This is the question I kind of now ask myself all the time since the pandemic. Like, which algorithm would you bet all your chips on? Like, if this was the next version of a pandemic and you had to choose an algorithm to scale high-quality education, are you going to throw ChatGPT at it? Maybe. That would be reasonable. But even several years on, now that we're at Code in Place 5, I would still throw my chips into this informal teaching algorithm. This idea that people who have just learned recently, people who are older, people who are younger, no matter where you are kind of in this world, there's a joy to teaching. And that joy of teaching can allow for a classroom that is social, that is engaging, that has mentorship, that has all those things that us as a human species really crave. And maybe most importantly, it's giving the teachers an experience that can be very valuable. We might see a society where it's harder to go from learning computer science to getting your first job. If you're a great computer scientist, there's wonderful things you can do. I think there was a question about, should we still learn to code? We had double the amount of people apply to Code in Place this year as ever before. I think people are voting with their feet that actually learning to code is more important in 2025 than ever before. You can just create new ways with it. It is the mother tongue of large language models. But, sorry, I got distracted on the learn to code piece. There's nothing like teaching if you really want to master. If you want to get the entry-level job, there's nothing like teaching for building the mentorship, to building the experiences that might actually help you get that first job in the workforce. So, I will keep asking myself this question every day. I invite you guys to ask this question every day too. And 5 years on, my answer still is informal teachers. I think we really underestimate how valuable they are. We'll sprinkle AI in. It will continue to be part of the conversation, but that's, I think, one of the most impressive things that I have seen. Okay, at this point, I've got time for questions. Thank you guys so much for being so patient. I would love to have this conversation with you guys.
Please come to the microphones if you have questions. Maybe I'll start with one, which the data on the GPT tutor thing are really interesting, and we've had discussions in we were just doing some chatbot-based paper reviews in my graduate course last week, and we had a discussion about I think some of the students found it kind of demoralizing that that one of these models can actually do about as well as a human can at reviewing a scientific paper, right? And presumably that's the demoralization that you might be seeing there. So the question is do you think there are tricks to kind of smooth that over?
Okay. So the observation is maybe the things we're seeing is because of demoralization. And that's scary. Why is that scary? Because maybe motivation is one of the most important things in all of education. If somebody really cares about what they're learning, there's nothing you can do to get in their way. They'll figure it out. They'll find the open science textbooks. And if somebody doesn't care, if they're not motivated, there's nothing you can do to help them. You can give them perfect pedagogy and it won't get them there. So that would be scary. Okay, but your question was, what can we do to kind of maybe smooth this over? Because we live in a time of large language models. I think that's why you might not want to inundate a student with large language models at that vulnerable moment. I think giving it to them later in their programming careers is great, but not at that moment where they're struggling so hard with for loops. It's just too demoralizing at that time. I think the other thing we can do is give them that sense of creation. I feel like that can help too. That sense that you will actually, in our generation, we will make more than any other previous generation. We'll be able to review our papers more, which means that we'll be able to, do something that the 40-year-old professor can't do. I guess that's me. Anyways, but I don't, that's a long way of saying I don't know the answer to your question.
Cool, thanks.
Thank you.
Hi, I'm Dhaval. I'm a computer science alumni, grad school. The question I had was on one hand, you have lots of these teachers who want to teach, lots of students want to learn, and then automation, right? And the ultimate goal of automation is to automate as much as possible. So where do you draw the line and how do you decide the balance?
Yeah, isn't that one of the reasons that education has been very fun for me to study from an AI lens because it's such a hard problem, but it's also been very complicated. In healthcare, if you automate something that maybe somebody just doesn't get sick or they have a solution to their sickness, but in education, you just can't do the work for them. The student has to do the learning, so I can have my fancy tool, but no matter how smart I get, students still must do the work. So automation can only go so far. I like the analogy, if we can remove some of the cruft, some of the uninteresting things. We can maybe make learning more joyful, but can't automate out the work, I think.
Hi, Chris. This is a wonderful presentation. I'm Anya. I'm from the education department. My question is, because I think many of your measures are focused on engagement, and I'm interested in your thought about the metrics in terms of the proficiency and efficiency, because you mentioned the job market, transition them to the workforce, and I think many people know that the leak code is still the way to get an entry job and even to transition job, and they're kind of boring. And I focus on efficiency and proficiency, so I wonder your thought on bridging the engagement and proficiency.
Yeah, you are right that my first observation is proficiency. It turns out once you start, engagement. Once you start losing students, proficiency gets really hard to measure. Because the GPT study, we gave them an optional diagnostic, but since one group had lost a bunch of students, I didn't know which students they lost. Did we lose the best students? Did we lose the students who are struggling the most? You could lose a bunch of students who are struggling, and the remainers who take the exam look like they're doing better. So it's a little complicated. I can do more experimentation code in place than I can do in my own classes, but I would like to tell you about one study that we did in my own class where we actually do have everyone take a midterm. But my guess from my experience as a teacher is that proficiency is getting a little bit better for the top end, and it's getting much worse for the bottom end students. You ask any teacher who's teaching university class, and they'll probably tell you about a feeling of bifurcation. I'm seeing students in my probability class achieving heights I've never seen before. I'm also seeing students who are showing up to the midterm not knowing how to do some real basics. And I'm feeling that pull. So maybe that speaks to proficiency. I think it's a complicated story where some people will get more proficient and some people may not. Can you remind me of the second question?
The question about the leak code is still the current the key to getting an entry job, and I wonder your thought about how to bridge engagement to make leak code more interesting.
Well, the bad news for leak code is really that now everyone can cheat on it, right? There's incredible tools for just pulling up and having ChatGPT do all of your leak code, maybe even part of your interviews, maybe even part of your exams if you're a university student. A total disaster for assessment. And so I think that will change. What do I do in my probability class? I now make all my students come and do a 10-minute conversation with somebody. No computer, just talking about probability as part of our assessment. I wouldn't be surprised if that's a future that assessment goes in, where you go to a tech interview and it's not leak code, it's just pencil and paper or whiteboard and marker exams again. I think we'll go back there. Preparing for leak code, do it with a friend. Thanks for the question.
Hi, Chris. Hey. So your GPT surprise made me think of the Bastani et al. Paper about Gen AI can harm learning. And so when you mentioned it, I was like, oh, is this going to be sort of a reinforcement of that? And I was curious to see that it was. And it made me think about something I've been thinking about a lot as a former teacher around using AI for grading. And so I have two questions for you in that regard. One major concern I have about using AI for grading is the potential bias, right? So LLMs have been shown to have strong social biases, right? Yeah. How do we prevent that from happening when we have it grading student work? Curious on your thoughts on that. And then the second one, you mentioned a lot of what the teachers gain from teaching someone else in the program. As someone who's been a part of a lot of near-peer teaching programs, I totally get that. And as someone who's taught teachers how to teach, I totally get that. One concern I have for teachers is if we offload that grading to AI, what then do the teachers lose? So two questions. Has the bias piece of it been solved using LLMs for grading? And then how do we handle what teachers might lose as a skill if they're not doing the grading?
Yeah, okay, wonderful question. The first one, bias, I think I should be very clear that what we've done, we have measured bias and we haven't seen signs of bias across protected demographics. But what are we grading? We're grading code and we're grading math where there's not that much leaking of people's demographics. I would be terrified to hear somebody use this for grading a history exam or grading something where there's a lot more opportunity for protected demographics to leak into students' work. And we'll keep monitoring that. I think there are measures of bias and that is a must. If you ever do grading, it's a must that you do your demographic bias analysis. The second question was, do teachers miss out by not grading? Yeah, they do. But we have some fun things to replace it with. So you know how we have this little tool where we have kind of teachers play this noticing game where we can give you student work and you have to notice what's wrong. And you get points on if your noticing helps a large language model predict how they'll solve problems in the future. So if you can really notice what a student is understanding and not understanding, you'll get lots of points. And so I think there's other ways that we can get this skill back for teachers. But you're not wrong that like grading was a great way for people to build that noticing skill. Looking at students' work and recognizing what's wrong with it, powerful muscle for a teacher.
Yeah, thanks.
Awesome.
One more question.
Hi, hello, Chris. Thank you very much for the presentation. My name is Ralph, and I'm also in AI in education sector. So we're providing like AI for elementary schools. But your point, so you are thinking about teaching the codings and for the people, and then to get to the Excel. But the thing is, my point is, AI itself has already started coding, and then as an employer, I know that when I post the AI jobs or like programming jobs, I'll get tons of applicants. If I post a job for a salesperson, I would just few of them. I would say this is a result of like in a bubble. Like 10 years ago, AI engineering, everybody jumped to the AI. Now it's AI, it starts coding itself. And sometimes I attend for the conference and they say, like almost 80% of the coding jobs will disappear soon in the future, in the upcoming 5 years. So because of AI, start coding that. So what is your vision on that? So why we need people to jump for the coding because already AI start coding it. So, and then I wouldn't recommend if somebody come in and they want to choose the future job, I wouldn't recommend them to start coding it and learning coding because our entry level of coding is already done by ChatGPT and a lot of like a serve, like a server, and then the other ones like with the $1 billion valuation. What is that? What your opinion about that?
Yeah, okay, no, wonderful question. So AI is really, really good at programming. Does that mean that people shouldn't learn to program? And there's actually two versions of that. People learn to program for careers and people learn to program just for other reasons. You know, I was ready, I recognize this, you know, I got early access to the ChatGPT stuff and I was like, oh wow, this stuff's really good at programming. Should I start looking for a new career? Like people won't need to learn to program in 10 years. Lots of observations, so bear with me. The first observation is that that's not how people are voting with their feet. We are not seeing jobs disappear. We're seeing jobs become much more entrepreneurial, which I'll talk about in a second. And we're seeing people show up more for coding jobs, or coding classes. People want to learn to code more. That doesn't answer the question of it's a good idea, but that's just an observation. Why do I think it might be a good idea? One observation is I have a lot of people show up to me with really wonderful demos these days. It's incredible to see what people can come up with. But I can really quickly tell the difference between somebody who's a programmer coming to me with a wonderful demo and somebody who's not, because remember I showed you that book my daughter wrote? You can imagine it was fun when she first saw the image. You know it was a disaster? If we ever tried to change those images. You're like, here's an image, let's change the hair color of the girl, disaster, like not gonna work at all. And we've all had that awful experience of like, okay, AI gave us a first draft, but trying to modify it is just the worst. Something similar happens with code. You ask AI for a code demo, it could give you a pretty wonderful first draft, but you want to modify that or change that, if you do not know how to program, it is the worst experience. And if you're doing a really small demo, that's fine. But if you're trying to make a bigger system, like say you're programming something like Code in Place, there's no way that works. And in fact, I have programmers who use a variety of AI support. And a year later, I can really see the difference between the people who didn't use AI support and were just being slow and methodical and building really wonderful pieces that we could build on top of, and people were kind of moving a little bit faster with the AI. That's really can hurt you down the stream. But there's this untold story, which I think might be important here. I think what people do with coding will be different. Right? I think people are learning to program so that they can be entrepreneurs. I think there'll be more people starting companies in this generation than ever before. Because two people who know how to program and can work with ChatGPT could probably make a pretty impressive startup these days. You can use ChatGPT to force multiplier coding. So if you can program a little bit, let's say you know the equivalent of CS106A, maybe the equivalent of CS106B, I think at this moment you've got like 100 times multiplier with ChatGPT. And if you didn't know how to program, you're not like 100 minus 1, you're like at 0. Not 0, but I think it's really hard to make something like a startup happen. So that's one piece. And then the final piece is, well, maybe there are not so many software engineering jobs, but maybe more disciplines will require coding. Maybe more disciplines will require you to use ChatGPT to its fullest extent, and ChatGPT's mother language is coding. Now, I'm not trying to sell people on these ideas. I'm just trying to explain this observation that more people are showing up to coding classes than ever before. And I've never really seen this rush, and I've lived through a lot of generations.
Gotcha, gotcha. And then you're saying this is something promising in the future, but I can't say that's something promising in the future because the volume is going to be really, really low the compared 5 years ago and then 5 years in the future. The volume of the engineering, like programming, will be, I think, substantially low compared to the 5 years ago and 5 years in the future.
I guess that presumes that every piece of code written leads to less programmers because it's already been written. And I think the opposite has turned out to be true. Every time somebody builds some software, it actually leads to more demand for more software in the future, which leads to like deeper problems and more need for more programmers. There was a time when we moved from machine code to Python. Programming probably got 100 times easier. There were a lot of programmers, and it was probably the case that you could now have one programmer do what 100 programmers could do before. And what we lived through was not we had 100 times less programmers. Instead, we had people producing more software, and that more software actually just drove up demand for software. So the fact that we could write programs quicker and fewer people could write as much programs as more people in the past, it didn't change. Like there was a really complicated demand thing that played out. So who knows what the future holds? Certainly not me. Any prediction I made certainly might not come true, but I'm just
Thank you.
trying
Thank
to
you
observe.
for sharing thoughts.
All right. Well, on that note, thanks very much again.
Cheers.